Hey everybody, it's Joel Irway here with dailyfeexamprep.com. Today we've got a member request from Chris who is asking for help with matrices and cofactors. So let's get right into this problem. So his question was if we could somehow calculate the cofactor matrices within the Casio FX115 ES Plus, and he gave me a problem to work out and I shared it with you. So he's got a series of equations here, which we're eventually going to configure into a matrices, but the question is asking him to give the cofactor matrix from this coefficient matrix. So some key things to remember: a cofactor, or also known as an adjunct, describes a particular construction of a matrix useful in calculating the determinant of a square matrices. It's also called the signed minor. Now, the minor is simply the determinant of some smaller square matrices from a larger matrices obtained by removing one row and one column. For instance, a 2x2 matrices is obtained from a 3x3 matrices, so that 2x2 matrices would be a minor of that 3x3 if we removed one row and one column. So if you reference page 31 of the NCEES Reference Handbook, version 9.2, the cofactor of this element is the value of the minor of the element. It's the value of the minor of the element if I plus j, which is rows and columns, if that value is even. And it's the negative of the value of the minor of the element if I plus j is odd. Okay, so if you're reading that from the supplied reference handbook, it is kind of a little confusing, so we're going to go ahead and we will clarify it for you in this video. So remember, I and j are corresponding rows and columns of a matrix. So the question that he gave me is, what is the cofactor matrix of the coefficient matrix? So in the question, they give us these three equations, which is the 10x plus 3y plus 10z equals 5, 8x minus 2y plus 9z is equal to 5, and then 8x plus y minus 10z is equal to 5. Okay, and he gives us four different potential answers. So I'll have you look at that, and in a minute, well actually right now, I'm going to cut over to my little chalkboard, and I'm going to work it out for you and show you how I would calculate this. So the short answer is you can't solve this entire problem with the calculator, but you can have it do part of the problem. So let's cut over to the blackboard and I'll show you exactly how. Actually, before we cut over, I want to give you the steps of how we're going to solve this. So first, what we'll do is we'll find the coefficient matrix. Then we're going to set up the cofactor matrix and the determinants of the matrix minor. So that's what the cofactor matrix is going to be. It's the determinants of the matrix minors. So the way that we do that is we choose an entry from Aij, which is just a selection of the row and column from the matrix, and then we cross out the entries that lie within those corresponding rows, and we'll find the determinant of each entry, and then we're going to build a new matrix. So remember, if I plus j, meaning the row and column, is odd, we're going to multiply the determinant by -1. So that's critical in this problem because we're going to have some that are going to be somewhat similar but just off by a negative value. Okay, so here we are, and what I want to do for you over here on the little chalkboard here is I want to kind of walk through and show you exactly how we're going to solve this problem. It's actually not as bad as you might think. You just have to be able to identify the key terms that they're looking for. So the question again is, what is the cofactor matrix of the coefficient matrix of the following three equations? Okay, so the first thing that we need to do is we need to find that coefficient matrix. We really can't do anything until we define that coefficient matrix. And the coefficient matrix is exactly what it says it is. It's the matrix of all of the coefficients of the variables, the x, the y, and the z. So all you need to do is just go ahead and write out all of the coefficients. So that 3x3 matrices, because we have three variables, or three coefficients, for three formulas, so it's a 3x3 matrix, and just write it out as exactly how you see. So we have 10, 3, 10 for the first row, then 8, -2, and 9, and then 8, 1, and -10. So that's the matrix that we're going to be working with, and that's the matrix that we need to find the cofactor matrix of. Okay, so that's step one. Now step two is we need to find the determinants of the matrix minors. So the way that we're going to do that is we need to cross out the corresponding row and column and replace it with the elements that are left. Okay, so for example, if we were to do row 1, let's see if I can get this drawn on here, make sure I've got the right ones. So if we were to do this row 1, column 1 coefficient, we want to find the cofactor. So we need to find the minor matrix. So when we do that, all we're doing is we're crossing out the row. So actually it's going to be this one, and I'm sorry, the column, and then the row. And so what we have left is the minor matrix right here, this 2 by 2 minor matrix. Okay, so we have the cofactor of 1, which is row 1, column 1, which is I and j, is equal to the minor of -2, 9, 1, and -10. So if we find the minor determinants of this minor matrix, we will get the determinant value of the cofactor matrix in this 1, 1 position. So how we're going to use the calculator is, all we need to know, sometimes doing these determinant calculations can get really confusing. So this is what I want to use the calculator for. I don't want to screw up my calculations here, because you need to make sure you carry over the right sign conventions and you're subtracting and adding the right one, so it can get a little confusing. So I use the calculator to determine the determinant of the minor matrix. So if you realize how to come up with a cofactor matrix, you should be good to go, and then use your calculator to come up with that determinant. But so anyway, what we're going to need to do is basically identify in the calculator that it's a 2 by 2 matrix, and then input the 2 value, or the 4 values. So we're going to input that -2, 9, 1, and -10, and then just have it spit out. You can actually have it tell you to calculate the determinant of, let's say we're going to define this as matrix A, and it will give you a value of 11. Okay, so we know that 11 is going to go right in this new cofactor matrix, so the value of 11 is going to go right here at 1, 1. So when we add up I and j, which is, remember, it's the row value and it's the column value, so I plus j is equal to 1 plus 1, which equals 2. So we know, since it's an even value, since 1 plus 1 is an even number, then it's going to be a positive value. If it were an odd number, let's say 3 or 5, then we have to multiply it by -1. But it's not. So we know that this value in the cofactor matrix is going to be positive, so it's going to be a plus 11. So if we go back to the original multiple choice answers, we need to find the one that's plus 11 in the 1, 1 position, and that's how we're going to know what our correct answer. So we don't even have to solve the rest of the 9 values. That could take a lot of time. All you want to do is work backwards and figure out which one is matching up with our answer. So you only really need to do 1, maybe 2 calculations. Okay, so that's how I would solve this problem. And so moving forward, what I want to do is I'm going to cut back over to the slide deck, and I'm going to show you how to calculate determinants in the Casio FX115 ES Plus. So that's where we're head right now. Okay, so welcome back, and what I'm going to do right now is I'm going to walk you through how you would solve this in the Casio FX115 ES Plus calculator. Okay, so like I said before, it's actually a very simple problem as long as you can set up you know how to set up that coefficient matrix and know how to determine a minor matrix. So Once you get to that point, now you can use your Casio to automatically calculate a determinant of one of those minor values. Okay, so what I'm going to do is I'm going to walk you through a sample of how to find the determinant of the minor matrix using from position 1, 1. So I1, J1, row 1, column 1. So what you need to do is click your mode button and follow along here. So all you do is hit mode and tell your calculator that you want to define a matrix value. So you hit 6 to select matrix. Then what you're going to do is just define one of the matrices. You can do one of 3 matrices, and for this one I'm just going to do matrix A, which is button number 1, and then I have to define that it's a 2 by 2 matrix, so I hit button number 5. Once I do that, it's going to automatically give me a 2 by 2 matrix, and now I just need to fill it out. So if we look at the problem, that's actually supposed to be a -2, so it has to be -2, then you hit the equal sign to move over, and then you hit 9 equal sign, and we're going to go back down to the next row, then we hit 1 equal sign, then hit the negative key. It's not the minus key, it's the negative key over on the left hand side. Then you hit in 10, hit equals, and then hit the AC button to go back to the main screen. Now what we need to do is we need to input it into the formula bar. So what we're going to do is now, once we're back to our main screen, we hit Shift 4 and input number 7, which is the determinant. So we want to tell the calculator to calculate the determinant of matrix A. So we're going to hit Shift 4 and then 7. Then we're going to hit Shift 4 again. This is going to bring us back to that matrix screen, and hit 3 to input matrix A. Then we hit equal sign to solve, and it spits out 11. Now I want to stress the importance here. It's going to be up to us to determine the sign convention because the calculator doesn't know what position in the matrix we just calculated. But it's very simple. Just calculate the simple addition of row plus column, and if it's even, we're going to multiply it by a +1. If it's an odd value, we multiply it by a -1. Okay, so I hope you enjoyed this video, and I look forward to teaching the next one for you, so I'll see you in the next video.